The 80s, some would say the coolest of all decades. But then, news broke.
Scientists studying the atmosphere over the polar regions are now thoroughly convinced that man-made CFC gases have severely damaged the ozone layer.
A hole in the ozone layer was discovered, and we were on track to destroy it by 2050. Without the ozone layer, harmful radiation would reach us, with severe consequences for life on Earth. But today, we all know the good news. Earth's ozone layer is on track to make a full recovery. In an unprecedented act, a landmark agreement was signed, preventing a potential environmental disaster. Well, how do we do it? And what does space have to do with it? Let's start with the basics. The ozone layer is a thin part of Earth's atmosphere that absorbs most of the ultraviolet radiation from the sun. When depleted, this radiation can reach the surface, causing harm to humans and other living things. Ultraviolet rays damage DNA and cause sunburn, increasing the long-term risk of problems such as skin cancer. So, what caused the ozone hole in the first place? Chemicals used as refrigerants for air conditioners, spray cans, and refrigerators called chlorofluorocarbons were blamed for eating away at the ozone layer. In 1985, scientists from the British Antarctic Survey discovered the extremely low ozone concentrations over Antarctica and raised the alarm. They realized that the seasonal loss was getting worse each year. Shortly after, the Montreal Protocol was signed by every nation in the world and restricts both the consumption and production of these ozone-depleting substances, making it one of the most successful international agreements in history.
The remarkable thing when considering that is to remember that it only took 2 years for the world to take notice of the warning that the hole in the ozone layer was damaging the entire globe, for the nations of the world to take action. And that saved the world from major damage.
Today, the ozone layer is slowly recovering and is helping to shield us from the devastating effects of ultraviolet radiation. And by 2050, is projected to make a full recovery. How do we make sure we're on track? Satellites orbiting above us, combined with ground-based measurements, are the best way to do this. ESA has been monitoring the ozone for over 2 decades. Ozone data was provided by 3 key satellites: ERS-2, Envisat, and EUMETSAT's MEDOP satellites. Then, in 2017, the Copernicus Sentinel-5P satellite was launched.
Sentinel-5P, with its tropometer instrument, provides a series of trace gas measurements in nadir few. This means total columns, and one of them is total ozone. What is really important for the tropometer instrument, it provides this data with global coverage on a daily basis and through to its sensitivity with high accuracy.
So just how big is the ozone hole now? As we know, the size of the ozone hole fluctuates on a regular basis. Some years, the ozone hole is bigger and longer lasting than others. Normally, from August to October, the ozone hole increases in size, reaching its maximum between mid-September and mid-October.
With the tropometer instrument on the satellite Sentinel-5P, we monitored during the year 2022 a quite big ozone hole over the South Pole. This ozone hole had more or less the same extension and duration as during the years 2021 and 2020. In comparison to this, we saw during 2019 a very special occurrence of an ozone hole that was really much smaller than all other ozone holes, and this was caused by warm air slowing down the winds around the South Pole.
When the Antarctic hole eventually shrinks, it's projected to be smaller than 8 million square kilometers. Sentinel-5P's ozone data is also used for daily forecasts of ultraviolet radiation and supports public warning systems. This allows people in certain areas to choose whether to stay indoors on days when ozone concentration is particularly low. The data also filters into the Copernicus Atmosphere Monitoring Service. This service combines measurements from different satellites and ground-based sensors with numerical models to provide policymakers with information about the state of the ozone layer, as well as predict how it will change in the future. At the moment, our satellites provide us with a downward view of ozone concentrations. But these data don't show us how the ozone varies with height. But soon, a new satellite scanning the atmosphere will provide us with a new view of ozone profiles. The Atmospheric Limb Tracker for investigation of the upcoming Stratosphere satellite, or ALTIUS, will carry a high-resolution imager that observes ozone backwards. But what does that mean exactly?
Sentinel-5P is a satellite that is looking downwards, providing total ozone columns, whereas the future satellite mission ALTIUS is looking backwards, scanning the atmosphere and providing height-resolved profiles of ozone. And the advantage of these profiles is that they can be used in modeling, and by using this profile information you get better predictions of the ozone as compared to using total ozone columns.
This limb sounding technique will allow ozone to be viewed at different altitudes, providing us with a better insight in monitoring long-term ozone trends.
The satellite mission ALTIUS is really very important as it will extend vertically resolved information of trace gases in the atmosphere. Current existing satellites that are providing this information are already quite old. So we are really looking forward that this European mission will contribute to this kind of monitoring of the atmosphere.
Along with ALTIUS, the upcoming Copernicus Sentinel-4 and Sentinel-5 missions will also monitor air quality. Both satellites will provide information on atmospheric gases, including ozone, to support European policies. So what have we learned? The production and consumption of ozone-eating substances has dropped, and today the ozone hole has stopped growing and is now slowly shrinking. Satellite data are paramount for ozone monitoring. Fast ozone action sets a precedent for climate action and demonstrates what happens when nations get together. We can make an impact.